Welcome to all. I am Vidhyalakshmi, PG and Research Department of Computer Application, St.Joseph College of Arts and Science, Autonomous, Cuddalore. Today we are going to see a video on subject software engineering. In this subject, we are going to discuss about the topic white box testing. White box testing. It has lot of names. Some of them are glass box testing, clear box testing, structure-based testing are some of the names given to the white box testing. Why? Because inside a model, each and every lines are tested. If there is a glass box, we can able to see what is inside. Similarly, white box testing means each and every line inside the code model can be seen or tested. That's why it is having the name white box testing. And then white box testing is basically test case driven technique. That means you should have a knowledge about the lines written in the program so that you can able to guess the input for the variables or the control structure inside the program, and then you have to examine the output whether it is giving a required output or not. That is called white box testing. That means you have to assume the input, you have to check whether it is giving a needed output or not. That is called white box testing. White box testing guarantees some of the things following. It guarantees whether all input paths within the model have been executed at least once. That means it checks each and every independent path is executed inside the program, and it checks all the logical decisions in both sides, true or false side, either in true side or in false side. It guarantees and executes and checks all the loops with their boundaries as well as within their operational bounds, and also check internal data structure to ensure their validity. So, white box testing has 4 important work. There are a lot of types and techniques inside the white box testing, but in this video we are going to see about basic path testing, one of the type in white box testing. If you ask what is meant by basic path testing means, it is a method that enables the designer to check whether it executed all the lines in the program at least once. This is the first usage of basic path testing. And another use is the designer can be able to measure the complexity of the model. The basic method is using in 3 ways. First, the designer can be able to check the logical complexity measure as well as it check each and every lines in the program is executed at least once. This basic path testing is proposed by Tom Michael Cap, and this is a basic as well as simplest method in the white box testing technique. Before moving to the basic path technique and how it is working, let me see about the notation what used inside the basic path testing. We know already how the flow chart will be. The same thing, the same similar thing is followed in another way. It is called a flow graph notation. In basic path, they use the notation called flow graph notation. This is an example for flow graph. The same flow chart designed in a flow graph here. They join the condition as well as the sequence statement as a single one here. If there is no path moves out means if in the box number sequence statement 2 there is no path moving out from the node. So they have joined the 2 and 3 as a single node here. A flow graph is a representation of a control flow. Each circle inside the flow graph is called node, which represent one or two statements. You see here each and every circle is called a flow graph node. It includes one or two statements. It is a representation of control flow inside the program. And then we can map a decision statement as well as sequence statement into a single node. As I told already, here this is a sequence statement, this is the decision statement. Both are combined together as a single node. If the node is having a condition, then it is called as a predicate node. The lines here is called as edges and links, otherwise links. Then an important thing what you have to know about flow graph is regions. A region is nothing but a bounded area by edges and nodes are called region. When counting region, we also include outer side of the graph also one of the region. For example, here if you see, this is a closed area. So this is one of the region. This is also one of the closed region. Here you can see another closed region. This is an outside region. The collection of total number of regions inside this flow graph is 4. Then if there is a condition, what will happen in a flow graph notation? A compound condition and or XOR like that, if it is there means each node is noted in a different way. A condition is represented in a node called predicate node and it is characterized by 2 or more edges coming from that. For example, you see here a B is having a condition. If, for example, if A or B, then procedure X to be executed, otherwise procedure Y should be executed. This is the working flow of if statement that is represented in a flow graph. Here, if A is true, then X should be executed. It is represented here. If B is true, then what? Y is to be executed. So, like this, if or and non XOR conditional statement will be represented. Then here we are seeing the independent path. An independent path is any path in the program that introduce a new set of processing statement or a condition. Independent path in a program is it should start from one node and should end in another node, exit from the model. But one independent path should differ from other independent path at least by one edge. It has to give a new set that should be not traversed before. That is called the independent path. For example, you see in this graph, we can move from 1 to level, that we can exit from the model. 1, 1, 2, 3, 4, 5, 10, level 1 is another path. That means from first path we compare to the second path, there is a new edge. Lot of edges is here. From 2 to 10, all are new edges compared to the first path. And we are moving to the third path. When we are comparing all the threes, all three are unique. Why? Because 6 is here, 8 is 6, 8, 9 is not in path 2 as well as in the path 1. So, independent path is the one which moves from starting to ending or exit from the model, which introduce a new edges. That is an independent path that has not been traveled by previous path. For example, this is not an independent path. Why? Because all the nodes are here are repeated only. We can't able to find a path that is having the new edge which was not seen in the previous path. So this is not an example for independent path. Independent path is the one which should have a edge which is not travelled by other path. Cyclometric complicity. We can find the cyclometric complicity in three ways. First way is number of region is equal to the complicity. Here number of region is 4, so complicity is 4. Then by the second way, we can find out the complicity of the graph by using the formula E minus N plus 2. Where E is the number of edges in the graph, N is the number of nodes, and we have to add 2. Let me check in this graph. Here number of edges is 11. 1, 2, 3, 4 like this. If you count number of lines here, it totally gives 11. The number of nodes is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of circles 9. By adding and separating 9, we get the answer 4. This is the second way of finding the complicity. And third way is number of predicate node plus 1. You see here number of predicate node is 3. Here a node which is having 2 or more edges, then it is called as a predicate node. You see here 1, graph is 3. By adding 1, we get the value 4 that represent the complicity. So, and final case is you should derive the test cases. Test cases means you have to find out input values. What are the input values, and you have to know what may be the result for them. Then you have to compare and check whether you are getting the expected result. That is the process. That process is called driving test cases. So these are the steps you have to find out are used to white box testing. First, by using the code, you have to draw the flow graph. Then you have to find out the complicity. Then you have to find out the independent path. Then prepare the test cases and compare the execution flow as well as expected result. Thank you.